All right, let's talk about some math for a second. Did you know that the latest research on distance learning says that people have trouble connecting with just like a head and an upper body? So in that last sequence, I was just strolling up to show you that I'm a real person and I'm on the computer every day like you guys are, checking your progress. I think we can do this.
Geometry. Again, I'm Mr. Mitchell. As you saw at the beginning here, I'm a real person, and I work with Mr. Scott and Miss Sitek on geometry. The topic today is kind of a greatest hits of a section in your book you can see here on the screen. It's called 1.5. So I'm going to turn my picture off. This is me talking. I will be drawing here, and I've got one piece of paper out to make the notes. Here I go. So angles is our topic. Okay, so today is August 27th. Angles. And 1.5 in textbook. Okay, so that gives me a place to start. I can go back and look at my notes later and figure out what I was doing. On the left here, you can follow my cursor. We're going to name angles, measure and classify them. We're going to think about congruent angles, and then we're going to bisect them for sure. And we'll see how much we do. We're going to do an angle addition postulate to work out some figures, some numbers for angles. Okay, so angle basics. I'm going to draw one freehand. I'm going to lay down a point. We're getting used to geometry here. I have a ray coming off of my point in that direction, and I have a ray coming off of my point in this direction. So the angle is the set of points. So it's a description, a mathematical description of this space. This is the angle. Okay. So this is what gets measured. This can be measured. A little more vocabulary. This point here, this is the vertex, where the two rays both have their origin. And then they'll talk about side. So this is like side one, and this is side two. So there's two sides to an angle. If I drew this again, all right, this is the interior of my angle. And I am going kind of quick because you guys now have access to the textbook. You can review this. And this is the exterior space. The exterior space for the angle is everything outside of this. The region that contains all points outside the angle is the exterior, the outside. All right. Let's think about naming an angle. I need 3 points to name an angle. I need 3 points to name an angle. Okay, to demonstrate this, I am going to bring up this. A company called Desmos has features online, interactive math. You've probably seen one of these before. This is a protractor. And I'm going to use it to demonstrate naming. So the red part is our featured angle. Now, if you look here, you'll see the number change. You'll see this 10 change as I move this red dot around. My angle's getting bigger. So the red part, that is the interior of the angle. getting bigger, and it can get as large as 180 degrees. If I want to name one, well, let's see, I like this one back at the beginning here. I see 35 degrees, and the way to name this is to read off 3 points. The O will be in the middle. Okay. I can say either angle AOB or angle BOA. I can say both. I'm going to go back to my screen and show you. So I'm going to try to draw that one. Okay, I've got points A, O, B. I can say this is angle with a symbol A, O, B. I can say this is angle B, O, A. On occasion, you'll see people refer to an isolated angle only by the vertex. So this is angle O. This is the vertex naming. And then lastly, sometimes you see a number written into a figure. So I'll make this a little number 1. And you'll see references to angle number 1. 4 ways to name an angle. Okay, so to bring some of these back up, just listen to my voice for a second. You don't have to write, just listen. This would be angle AOC. 65 degrees is the measure of the inside of it. You could also call it angle COA. This is an acute angle because it is less than 90 degrees. Let's move. Let's come over here. This is angle AOD or angle DOA. It is 110 degrees. It is an obtuse angle because it is greater than 90. So on the left, I'll move down to where all these are listed or in your textbook. If we had a point here, this would be a 90-degree angle, also called a right angle, 90 degrees. And lastly, this is a tricky one, 180 degrees. This one is also an angle. If you look to your left, a straight angle measures 180 degrees. It's opposite rays emanating from a point here. One ray goes this way, the other goes the other way, perfectly opposite. This angle does have a measure. It is 180 degrees, and you will see this in the scavenger hunt for today. Example 2, bottom of the page 39 in the textbook. Remember, these examples are worked out for you in the textbook. So they will cover some naming and classifications for 3 angles from a very similar piece here, from a protractor with points all over it. So I recommend having a look at this before we get to anything like a test or a quiz. Okay, constructions, we don't have the tools at home to do this. I am going to bypass some of it, but I'm just going to tell you that sometimes we refer to angles as being congruent. And they'll add a little extra letter. If they are saying that the measure of angle A is the same as, is equal to the measure of angle D, if they're saying these 2 things are equal, 2 angles are the same size, then I can say that angle A is congruent to angle D. This M stands for the measure of. So you guys are getting used to it now in geometry. There's multiple ways to say these things. In math language, I would say the measure of angle A is equal to the measure of angle D, or angle A is congruent to angle D. This symbol, to remind you, means congruent. And this is the last small piece I will cover here, which is where they bring algebra in on top of the geometry. Here's a postulate. Recall, in the past, we've said that these little chain link objects in your textbook, those are important to think about. They're a great way to skim a chapter before you look more deeply at it. Postulate. If P is in the interior of this angle, RST, so they're saying point P is on the interior, then the measure of angle RST is equal to the sum of RSP and PST. So they've broken the measure of RST, this one, down into two parts. Here's half of it, RSP, and here's the other part, PST. This postulate tells me that if I add the two pieces together, I will get the sum of the whole. So I can add two angles together that are on the interior side, that are interior to the angle. I can add these two angles together and sum to get the measure of the entire angle. Example 4 will have you work through that, and now instead of an angle, they've given me an algebra expression. This tells me in the example the measure of LKN, which is here, 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 is equal to 145 degrees. And it's obtuse. It looks like it is greater than 90. They've used this postulate to set this equation up and solve for x. So they're saying 145 degrees is this angle, 2x plus 10, and added to that, 4x minus 3. Add those two angles together. There's an equal sign in here. Now we can bring in algebra and solve for x. We'll skip those steps for today. X comes out to be 23, following techniques from last year. Plug x back into these two expressions, 2x plus 10 and 4x minus 3, and you can solve for the angles that make up 145 degrees when added together. I want to mention one more topic from the bottom of page 42. So I would scroll in my case, and this is bisecting angles. To bisect something means to cut it in half. And here they say that an angle bisector is a ray that divides an angle into two angles that are congruent. So in this figure on the left, the ray YW bisects the angle XYZ. That makes two congruent angles. The angle XYW is now congruent to the angle ZYW. They are the same size. And in geometry, you will see this symbol drawn. I'll do it one more time on my paper. You will see these little hoops drawn. They're often offset. This means congruent angles. Hey, that's it for now on angles. You should have a scavenger hunt loaded to your Google Classroom. These notes are for you to keep. I would farm through the textbook and see what you can learn. And then you'll go out and find some geometry items from your home or wherever you are again. You guys have a great rest of your day. Thank you for your work.